And this is the last most complex topic on the test. Um, so if this is your first class or if this is an early class that you're taking, uh, by no means do I want you to be intimidated or frustrated by this material. Yes, this is part of the test. These are higher level questions. You're actually only going to see these questions if you're on your way to getting a good score on the test, or a really good score. But this is the last most complex topic. So this isn't representative of other story problems or arithmetic or algebra or geometry. These are the higher level questions that you'd like to see if you're scoring, a really superior score. But you don't have to be a master of this stuff to get a good score. So take it for what it's worth. Yes, you'd like to know this, but also don't fixate on it. Combinatorics is sort of the flip side of the coin from probabilities. Probabilities are, what are the chances of this one thing happening? And combinatorics are, how many different combinations can I make out of all these different things? And the most, textbook example of this was, if I have 10 paintings and I have 5 places on my wall to hang them, how many different unique combinations of 5 paintings could I make on that wall? And that's really it. So you can see that, sort of like probabilities, if you're dealing with a small number of values, 4 or 5, 6, like maximum, you don't have to use the special notation or something. You need to be able to recognize it when you see it, but you can draw that out on paper. I mean, you could literally draw 5 squares and then start drawing arrows, to your 10 paintings, and start to get an idea of it. Again, realize that your job is to select the correct answer, not necessarily to solve it out. Don't let them get you to make things harder than they need to be. And certainly don't let them get you to take all day working on a problem. If the problem is taking you well over 2 minutes and you're really not sure you're on the right track, discretion might be the better part of valor at that point, to say, I'm really not sure I'm going to get this question right, but at least I'm not going to let them make things worse by wasting 4 minutes or 5 minutes on it, and then not having enough time to answer questions later on that I might have gotten right. So it's a combination of getting questions right, but also the time factor. And you should never end up being in a hurry, because you know how much time you've got when you start the test. Budget it appropriately. And if a question's taking you a long time and you're really just not confident, it may be best to select the best answer choice you can and move on. Don't spoil your chances of getting other questions right later on because you took up too much time. So if you'd scroll down to about the center of the page, let's look at a really easy example. Let's say that we needed a password for the computer network at school, and it was just going to be 5 letters. Now, because everything on this test is just based on the American standard, you do need to, know this little detail, that as far as American English is concerned, the alphabet contains 26 characters, period. No more, no less, no fewer. It doesn't contain any official characters with accents or any diareses or combination of diphthongs or anything like that. It's 26 letters in the alphabet. And so if we could have, and there's a parallel idea here in combinatorics. With repeats allowed, you can see that's really the same idea as we have in probabilities with replacement. And so that's the idea of repeats allowed is the same thing as replacements. Repeats not allowed means without replacement. And then you've got the same idea of independent events versus dependent events. So if you have a password that's 5 letters long, not worried about caps, not worried about repeats, you have 26 times 26 for the second, times 26 for the third, times 26 for the fourth, times 26. All independent events, repeats allowed for each of those. That gives us 26 to the 5th power. That's a very large number of combinations. Whereas in probabilities, our numbers get smaller and smaller and smaller really, really fast. In combinatorics, our numbers get larger and larger and larger really fast. The more liberal we are with our requirements, the more possible outcomes we're willing to allow, the larger and larger and larger that number gets. The flip side of that coin is, as soon as we start placing limitations on it, those numbers start to get much smaller really fast. And that can be very helpful, again, when you're looking at the answer choices. They're arranged in value from least to greatest. Do I need this very large number, or do I need this much smaller large value? A lot of times that's all it's going to take for you to select the correct answer. And that's a lot easier than solving it out yourself. Okay, and if you look, read this bottom paragraph, please, at the bottom of the page. My voice is giving out a little bit today. Please check that out. Just like in probabilities, at the bottom, this is the notation that they're using. I don't want you to take your time to write things out in that format, but I want you to be able to recognize it when you see them using it. So if you would, put up a green check mark when you're comfortable with this page. Okay, so, don't